Welcome to The Explainer. Today, we're jumping into one of the biggest topics out there, but we're going to do it by cutting through the noise. We're just going to follow the data, use these slides to tell the story of our planet's fever, and maybe more importantly, explore the incredible innovation that's rising up to meet this challenge. So let's get right into it.
So this is where our story begins, with this number. In 2023, the amount of carbon dioxide in our atmosphere officially shot past 430 parts per million. And to give you some context, for the last 800,000 years, it never, ever went above 280. That's a huge jump.
Now, I know what you're thinking. 430 parts per million. That sounds like nothing, right? It's just 0.04% of the air we breathe. So how in the world can something so tiny be changing, well, everything? That's really the core question we're going to unpack.
All right, so to get to the bottom of that, we have to start with a proper diagnosis. Just like a doctor trying to figure out a fever, we've got to get our terms straight first. It's the only way to really understand the problem.
Okay, so you hear these two phrases thrown around all the time, right? Climate change and global warming. Climate change is the really broad term. It can be caused by all sorts of natural stuff. Think volcanoes or even tiny wobbles in the Earth's orbit. But global warming, that's what scientists are zeroed in on right now. It's this specific, incredibly fast heating of the planet, and it's being driven pretty much entirely by us.
So how does this whole thing actually work? Well, it all comes down to the greenhouse gas effect. The simplest way to think about it is like a blanket around the Earth that traps heat. And what we're doing is, well, we're making that blanket thicker. We're adding an extra 3 watts of energy to every single square meter of the planet's surface. That's like stringing up 2 extra Christmas lights over every single square foot of the Earth and leaving them on, 24/7. And when we look at what's actually thickening that blanket, the data points to one main culprit. Yeah, there are a few other gases involved, like methane, which is super potent in the short run, but CO2, carbon dioxide, it's responsible for a full 2/3 of the warming. And the real kicker? It sticks around for hundreds of years, which makes it the single most important factor in our planet's long-term fever.
Okay. So, the problem is CO2. But where is all of it coming from? And just how far out of whack are things? Well, the scale of this it's honestly hard to wrap your head around. A lot of people ask about natural sources like volcanoes. It's a fair question. But this chart, wow, it just lays it all out. All the volcanoes on Earth combined, they release less than 500 million tons of CO2 a year. Human activity? We're pumping out over 42 billion tons. That means we are emitting over 100 times more than every volcano on the planet every single year. It's not even close.
And let's zoom out. Let's look at the long-term history. For almost 1 million years, CO2 levels just bounced up and down in this really stable, predictable range. Then, right around 1815, something changes dramatically. In just a little over 200 years, we've created this insane, almost vertical spike. We've pushed our atmosphere into a state it hasn't seen in a very, very long time. And just to be crystal clear, we can't point the finger at the sun for this one. The data is really straightforward. While our planet has been getting hotter and hotter, the sun's actual energy output has been on a slight downward trend since 1969. The extra heat isn't coming from out there, it's coming from right here on Earth.
So this carbon overload, it isn't just some abstract number on a chart. It has real, tangible, and honestly pretty dangerous consequences for the world that we all live in. And this right here, this is one of the most dangerous effects. It's what scientists call a positive feedback loop. See, that bright white ice acts like a giant mirror for the planet, reflecting the sun's heat back into space. But as it melts, it exposes the dark ocean underneath. And that dark water, it soaks up almost all of the sun's heat. That warms the water, which melts more ice, which exposes more dark water. You see where this is going? The warming process starts to fuel itself. And we are seeing the symptoms of this fever pop up literally everywhere. The area burned by wildfires in North America, it's doubled. The frequency of the most extreme tropical storms, doubled. Major droughts, you guessed it, doubled. And on top of that, these massive planetary systems, like the big ocean current in the Atlantic called AMOC, which is basically a giant conveyor belt that regulates weather for whole continents, it's starting to show signs that it's getting dangerously unstable.
So this is a really crucial point. The planet systems, they move kind of slowly, but they have a very, very long memory. The last time CO2 levels were this high, sea levels were 75 to 100 feet higher. Now, the reason they aren't that high today is because it takes centuries for that much ice to melt and for the oceans to fully expand. But what this means is that we've already locked in some really significant changes for the future.
Okay, the diagnosis is clear. The symptoms are severe, and I know, that can feel really overwhelming. But this is where the story pivots. We're moving from the problem to the treatment plan, to the blueprint for a solution.
Because this is not a story about doom and gloom. It's a story about a challenge, for sure, probably one of the biggest we've ever faced. But it's also about how that challenge is sparking this incredible new wave of human ingenuity all around the world.
Let's take hydrogen, for example. It's got a ton of potential as a clean fuel. But what's really fascinating is that not all hydrogen is the same. You've got gray and blue hydrogen, which are still made using fossil fuels. The real game changer is green hydrogen, which is made by splitting water using renewable electricity from solar or wind. That's a true zero-emission solution. It just goes to show you the source of our energy is everything.
So what does the actual global game plan look like? Well, it really boils down to these key strategies right here. First, we've got to transition our power grid to renewables. Then, we need to electrify everything we possibly can. Our cars, the way we heat our homes, you name it. And for the really tough stuff that's hard to electrify, like airplanes or making cement, that's where we need some targeted innovation and ways to actually capture carbon.
So that's the blueprint. But this isn't just theory, it's not just on paper. Let's look at some of the incredible companies that are turning these ideas into reality, like right now. Okay, take concrete. It's responsible for a huge chunk of global emissions. But check this out. Innovators have now figured out how to literally capture CO2 and permanently lock it away into the building blocks we use to make our cities. So instead of creating emissions when we build, we can actually build with our emissions. How cool is that?
And we're seeing the same kind of reinvention with steel. For centuries, making steel has meant one thing: burning a whole lot of coal. But in 2021, a company produced the world's very first batch of steel using green hydrogen instead. It's just a perfect example of how even our oldest, most carbon-heavy industries can be completely transformed.
What about flying? I mean, batteries aren't going to work for long-haul flights anytime soon. But get this. Companies are now using these huge fields of mirrors to focus sunlight, creating so much heat that they can turn captured CO2 and water back into jet fuel. It's basically creating a closed loop, turning pollution back into power for our planes.
And this wave of innovation is just exploding. I mean, think about this for a second. In Iceland, they're pulling CO2 straight out of the air and turning it into solid rock. In Finland, a company is making protein, like food you can eat, from CO2 and electricity. We have companies making vodka and perfume from captured carbon. Others are turning farm waste into this stuff called biochar that makes soil healthier and locks away carbon for centuries. It's happening everywhere.
So this brings us right back to where we started, with a choice. The data we've walked through has shown us the diagnosis, the severity of our planet's fever, but also a really powerful blueprint for the cure. The ingenuity is there. The technology is starting to scale up. The only unanswered question, the final variable, is our collective will to decide which path we're going to take from here.